now it's time for me to introduce the resource person for the next session, Dr. Ebenezer Juliet ma'am. It's a privilege to introduce her to the participants. Ma'am is currently working as Associate Professor Senior, School of Computer Science and Engineering in Vellore Institute of Technology. She completed her BE in CSE from Government College of Engineering, Tirunelveli in 1995, and ME CSE from Manonimam Sundarar University, Tirunelveli in 2004. She obtained a doctorate in CSE from Manonimam Sundarar University in 2013. Dr. Juliet has 24 years of experience in teaching, and she specialized in digital image and video processing, computer vision, healthcare analysis, and network security. She has attended 14 seminars and organized 5, participated in 15 workshops and organized 4. She also has taken part in 26 conferences and organized 9, out of which 2 are DRDO sponsored. She also has taken part in 9 FDPs and organized 1 FDP sponsored by Anna University. Ma'am's contribution to research field is over 11 years, in which she has published her works in 2 national, 32 international journals, and presented her research papers in 15 national conferences and 29 international conferences. Ma'am is an Anna University recognized research supervisor, and she has produced 3 doctorates, 1 under thesis submission and 1 is pursuing. She has also received funds for her research works, 2 students' R&D projects funded by Institution of Engineers India, seed grant of rupees 50,000 from VIT for an in-house project, and 2.1 crores from ICMR as co-principal investigator. Ma'am has authored a book named Python Made Easy for Beginners for the first year Anna University students. Dr. Juliet is a life member in ISTE, IEI India, and Institution of Telecommunication Engineers. Dear all, on behalf of all of us, I extend a very warm welcome to Dr. Ebenezer Juliet, and I'm handing over the session to her. Ma'am, please.
Thank you, ma'am. Thank you for your nice introduction. Am I audible?
Yes, ma'am, it's very clear. You can proceed, ma'am. Thank you, ma'am.
Good evening to all. First of all, I express my warmest wishes and congratulations to the coordinator of this subtle sponsor FTP with the title Artificial Intelligence and Edge of Computing. Dr. G. Vaisrinji ma'am, Principal, Dr. Shivanthi Adityanar College of Engineering, Tirushandur, Tamil Nadu. And congratulations, ma'am. It's a great pleasure to congratulate the co-coordinator of this FDP, Dr. D. Kesavaraja, Associate Professor, Department of CSE, Dr. Shivanthi Adityanar College of Engineering, Tirushandur, Tamil Nadu. I thank all the organizing committee members for inviting me to deliver the lecture on the topic application of web computing. Okay. Shall I start my presentation? Are you able to see my screen?
Yes, ma'am. It is visible, ma'am.
Yes, yes.
Yes, ma'am.
Okay, okay. So welcome you all to this Atal sponsor FTP on artificial intelligence, edge of computing. The title given to me is Application of Web Computing. So let us see the overview of the presentation. It starts with the edge computing, introduction about edge computing, and then followed by edge intelligence and application of AI in web computing. Then one project demonstration, that is face recognition based attendance system in the classroom as a web application. So let me start with the background of this edge computing. You all know that the concept of IoT. Everyone know what is IoT, then the various applications of IoT novel. So IoT refers to the network of physical devices or the network of vehicles or some appliances or other physical objects embedded with some sensor and software or network connectivity for the purpose of communication of data or the purpose of exchange of data. You know that the smart objects ranging from some simple objects to some complex object. So in our house also you find some smart thermostat, some smart water bottle, smart pen. So the ranging from small objects to some complex objects like some smart cars, smart buildings and smart cities and smart transportation and et cetera. So whatever may be the application, so the components of IoT can be organized in this architecture. That is some four-stage architecture of the IoT. Okay. So let me explain the four-stage architecture of the IoT. So here at the bottom, you see the things layer. Here you find the sensor and actuators. For example, some smart healthcare application means some biomedical sensors are there, like temperature sensor or the sensor which measure the blood pressure or which measure the electrical activity of the heart and so on. Okay. So the sensor and the actuators means take an example of smart car. Suppose in the smart car, suppose we want to activate the brake system means some motor is needed. Okay, that is called as some actuators. Okay, so these sensor and actuators form the physical layer or things layer of the IoT. Okay. Then above this layer, you find the network layer. In the network layer, you find the components, okay, hardware components and the software components and the communication protocol. Okay. So depending upon the application, the nodes may be connected to Wi-Fi or wireless mode or wired mode or wireless. So wireless mode means, Wi-Fi, Bluetooth and LoRa band, some long range communication means you go for like the LoRa technology. So these components occupy the next layer like layer. Then above this layer, you find a middleware. Okay, middleware. Here only you find the infrastructure for the storage and computing. Okay, computing. So here usually some machine learning algorithm or deep learning algorithms are run to find the result. Okay, to find some results based on the sensor data. Okay. So this form the important part related to this FTP. Okay. So the computing, this is the computing part, okay, computing part. So in some application, this computing part may be located in the device itself. That is on-device intelligence or on-device computing. In some application, this computing part may be located far away from the things layer or far away from the end user. So that is called cloud computing. That is IoT with cloud computing. In some cases, this computing facility is located near to the, not in the device, but near to the end user level or nearer to the things layer level. Okay. So this is called as edge computing. In some books, it is denoted as fog computing and fog computing. Okay. So this played a vital role in the FTP. Okay. Then above this, you find the application. Okay. So here it is provided with some user interface. Through this user interface only, the end user communicate or end user may avail the services of the IoT. Okay. So any IoT application component can be classified under this four stages. Okay. Okay. Let me explain with one example, one simple example. Okay. That is some smart car application, human activity recognition using the wearable sensor. Okay. Let us see how this, okay, what are the components in this application, how they are organized in this four-stage architecture. Okay. So in the objective of this application here is to monitor some elderly person. Okay. Elderly person or some remote patient, okay, patient in the remote location, their activity of the elderly person or some remote patient. Okay. So that's why it starts with the location of the patient. Okay, location of the patient. So here the patient or the person to be monitored is embedded with some sensor. Here the sensors are mostly the biomedical sensor. Okay, from the biomedical sensor, it senses the data and then it passes via the communication part. So here let us see what are the signals or what are the data that are retrieved from this wearable sensor. One is EMG. EMG means, electromyography signal. Then EEG signal, ECG signal, that is electrocardiogram signal, that is the electrical activity of the heart. Then EDA signal, that is some details about the skin activity. Similarly, breathing rate of the patient. Then some force. Force means some to measure the numbness of the body, then temperature of the patient, and some other one, some acceleration of the body and it. Okay, so these are some important signals measured through this biomedical sensor. Okay, they are passed to the or they are sent to the computing. They are sent to the infrastructure which perform the computing on the data. So it may be on the, as I already told, it may be on the device itself, or it may be located far away from the device things layer. It may be in the far away means like in the cloud platform, or it may be located nearer to the things layer. That is in the edge computation layer or in the edge layer. Okay. So the computation may be in the different places. Okay. So in the computation or in the node which perform the computation run the machine learning algorithm or deep learning algorithm, depending upon the complexity of the application. Here, some machine learning algorithm is enough for identifying this activity. So while running this algorithm, the output from this algorithm may be the activity of the remote activity of the patient. So the activity of the patient to be classified here is sitting, whether the patient is sitting or lying on the bed or standing, walking, jogging or running and it. Okay. So here we know how the components of the IoT occupy these 4 layers through this example. Let us see in this slide one smart care application with both computing facility. That is, it provides both edge computing facility as well as the cloud computing facility. Okay, so here in this portion you find the edge computing facility. Here you find the cloud computing facility here. Okay. So for example, consider one scenario. Here, through this smart care application, we can monitor the patient, okay, patient who is admitted in the hospital under some emergency. Okay, under some emergency. So the patient is fixed with some wearable sensor. Suppose at one time instant, the pulse rate of the patient goes suddenly. Goes very low suddenly means the patient has to be treated immediately. So he has to, that situation must be should be treated with utmost care. So if such data is sent to some cloud server for further processing means it takes much time to get a response, based on the sensor data. So in this, to handle this situation, we go for like edge computing. So in the edge computing, here the computing facilities. Okay, so in the edge computing, the computing facility is located very nearer to the patient, nearer to the patients. That's why we get the immediate response. So through this response, we can immediately call the emergency services like ambulance service or other immediate and service, immediate and caretaking service. Okay. So that's why we go for the edge computing here, edge computing. At the same time, the data can be sent to the cloud computing for
Please, ma'am, unmute yourself.
Ma'am, you are muted, ma'am.
Unmute your ma'am. Unmute.
Yes. So above this, you find a fog layer. Am I audible?
Yes, ma'am. Audible now.
Above this, you find a fog
Yes.
layer. The fog layer contains some network components, special network components for processing. Okay. So here you find some specialized router, specialized server, or specialized switches for handling, for doing this data processing and all. Then above this, you find a normal cloud layer. So here it stores the data for long-term analytics. So from this, you understand where the edge computing or cloud computing play the important role in the IoT. Another one example, here you see the autonomous car driving. Here also you find the use of edge computing and the cloud computing. Here in the edge computing side, you see the services of like object recognition, object tracking, some path planning, obstacle predictions. So these kind of services are running near to this car or nearer to the things layer, where some other task like that is high definition map. So autonomous car driving, you know the map details. Okay, so the high definition map details, model training, data storage, some other simulations are happening in the cloud platform. Okay. Okay, now let us define what is edge computing. From this background, we know. So the edge computing is the distributed computing model that stores and process the data closer to the user rather than in a remote centralized data center. So the advantage of edge computing rather than the cloud computing here is reduced latency. That's a major advantage. Then improved response time, can get immediate response based on the data processing results. Then after that, efficient data processing, some tightened security, some high level security also achieved through this edge computing rather than cloud computing. Okay. And another important advantage here is reduced cost. The same service can be achieved with less cost when compared to the cloud computing. Okay. So now the edge computing play the vital role in all IoT applications such as self-driving car, smart healthcare, smart cities, automated industry, then remote monitoring of hazards, then smart grid and predictive maintenance and all. Okay. Again, let us see some of the use cases where the edge computing play a vital role and how. Suppose one security camera is employed in a remote warehouse to monitor the items means the AI software installed in that security camera is used to identify the suspicious activity. So here in this case, the AI software send only the specific frame, not all the video frame. It sent only the specific frame which contains some suspicious event to the edge computing side or edge computing server for further processing. Remaining all video frames are sent to the cloud computing environment for the backup purpose or for long-term processing purpose. Similarly, an oil rig in the middle of the ocean means it uses some IoT sensor and AI solution or AI algorithm to detect the equipment malfunction before they wash. Okay. Then another one use case in a smart agriculture means an irrigation system in the remote farm field adjusts the amount of water it uses in the real time by detecting the soil moisture level. So in this, so these cases use the edge computing for taking the action immediately, for taking some action immediately, or if it needs some immediate attention or it takes, if it needs some emergency, okay, service means we can use edge computing. So here you see the same thing in the diagrammatic form, that is smart transportation. In the smart transportation, you find edge computing here, edge computing here. Similarly, smart sea monitoring application with edge computing. But these all are connected to the cloud computing for long-term processing purpose. Here you see what are the hardwares are needed for edge computing here. You know, the normal edge devices like sensor, like smart cameras, thermometers, then other sensors. Okay. Then in addition to it needs some processor like CPU and GPU. Then in addition to this, it needs some cluster of servers. Okay, cluster of servers. Here, you know, in the cloud computing, the computing facility is provided by single cloud server, single or centralized server, but the same computing is achieved here by means of some distributed, some micro server or some mini servers. But the mini servers are located nearer to the things layer or to the physical layer. Okay, that is called as clusters of servers. Okay. Then in addition to this, it has some, the edge computing needs some specialized gateway, specialized routers and switches. Then another one important thing about this edge computing hardware is the edge computing hardware needs to be durable and long durable one. That is because it can be deployed in the deployed under some sea, okay, under some sea water. It must be deployed in some forest area. So that's why the edge computing hardware needs to be durable one. So here you see the location of, okay, the spread of the edge computing, okay, hardware here. So here the outermost layer shows the location of the sensor and the actuators. Then within this layer, you find the next layer shows the hardware needed for edge computing, hardware needed for the edge computing set tower, then Wi-Fi router and the gateway. Then within this, you find some components needed for connecting with the cloud platform, connecting with the cloud platform. So it needs some internet connection. So for that purpose, it needs some internet and the connectivity devices and data. Okay. Then here within the innermost circle, you find the components in the cloud platform. Okay. So in this way, the components are arranged in the IoT with cloud computing as well as the edge computing. Okay. Okay. Now let us conclude that the edge computing is the main key infrastructure for the AI democratization or ubiquitous AI. Some 5 or 10 years back, we know the word like ubiquitous computing. That means computing everywhere, computing anywhere at any time. Okay. But through this edge computing, we get a benefit like AI anywhere or AI at any time, everywhere. Okay. So that's the benefit of edge computing. Okay. Through this edge computing, we are able to realize AI everywhere and anytime and all. Okay. Next, let us see some of the important points or advantages of edge computing rather than the cloud computing. So compared with this cloud data center, the edge servers are in close proximity to the people and close proximity to the data sources and the devices. Another one important thing is edge computing is more affordable one and accessible one. Another one important advantage is it provides, okay, through this edge computing, you are able to provide more diverse applications than the cloud computing. Okay, then these are the three special benefits of edge computing rather than the cloud computing here. So these are all various edge computing providers. In the last session, you know the edge computing in the industrial aspects. So here you see the various edge computing providers. That is a platform for edge services like IBM Watson, then Microsoft Azure, then hardware providers, then infrastructure providers, various infrastructure providers, then the network and connectivity providers, and the real estate providers, like they make an arrangement for infrastructure and all. Then software solution providers. These are the various edge computing providers. Okay, already we have seen. Okay. Now let us see what is edge intelligence. So far we see what is edge computing. Here we see what is edge intelligence. So what is edge intelligence means here, the migration of AI computing from the cloud to the edge layer. Okay, edge layer where the data is generated. So it's nothing but the integration of AI, artificial intelligence, and the Internet of Things and edge computing. So it's a combination of all these things. So it can be explored as, it can be extended as integration of IoT, integration of edge computing, artificial intelligence, machine learning, deep learning, data analytics, and big data and cloud computing. So it's an integration of all these concepts or all this technology. Okay. One more thing, it's a major steps towards the next revolution. Okay. That's a new revolution in the Internet of Things domain. Okay. So the edge computing is the new revolution in the Internet of Things domain. Okay. So we know what is edge intelligence here. Next, let us see why we need edge intelligence. Okay, why we need edge intelligence. So there are three important reasons I have quoted here. The first thing is growth of AI and IoT. Today we find and realize, we see everywhere, we see the AI-based application and IoT-based application. Okay. So because of this, the massive number of mobile and IoT devices are connected to the internet. Okay, so through this more number of IoT devices or mobile devices, it generates some data bytes. Okay, data bytes or data size in terms of zettabytes. Okay, zettabytes means in terms of a number followed by some 21 zeros. Okay, 21 zero. Imagine how much volume of data is generated through this growth of AI and IoT. Imagine here. The second thing is massive data generated at the network edge. So from one statistics that is provided by Cisco Cloud Index estimate that nearly 850 zettabytes are data collected in the year 2021, but the same thing in the year 2016 is only 20.6 zettabytes. Here you see how much growth is happening due to the growth of AI and IoT here. Okay. Another one reason here is as I already told that, so the cloud computing is gradually unable to manage these massive distributed computing power. Already everyone know that the IoT application is like a energy efficient, energy constrained network. IoT network is energy constrained network. Suppose you are going to choose one algorithm for IoT application, means always you concentrate on like energy efficient algorithm or energy efficient protocol and all, because most of the entities or most of the devices connected in the IoT is battery powered devices. Okay, in order to enlarge the lifetime of the devices, we go for like energy efficient protocol or energy efficient algorithm. Always we choose the protocol with energy efficiency. Okay, but in the cloud computing that is not possible. Okay, that is not possible because here the resources need large computing power. So this is a failure or lacking of the cloud computing when compared to the edge computing. Then another one thing is latency. Okay, here in the cloud computing, the devices are located far away, so it take much time or the delay is more here. Again, the deep learning algorithm also need more another bandwidth. Network bandwidth is more. Another one important thing is privacy, because most of the data transmitted too far away for cloud computing means here some breaches against the security, some attacks to the security or some security threats. There's a possibility for security threats. Okay, that's why here we prefer edge intelligence rather than the cloud intelligence. Okay. So here you see the comparison of all this intelligence. Okay, three intelligence on the device. So it is mentioned with some green color. Some intelligence on the edge. Okay, that is nearer to the things layer. That is gray. Then intelligence on the cloud side. That is in the red color. Okay, here these three intelligence are compared with respect to the desirable or preferable characteristics of any IoT application. Okay, here 6 characteristics are taken here. Consider one is latency, then scalability, reliability, and device whether it is cost effective one or then next one is diversity and privacy. Okay, among the 6 parameters, for all the 6 parameters, the edge intelligence actually stand first among the 3 intelligence. Okay, when except the privacy, for the remaining characteristics, okay, the edge intelligence always occupy the topmost positions. Okay, so that's why the edge intelligence or edge computing realize there is a booming for edge intelligence today. So here you see the comparison of cloud computing, fog computing, and edge computing. Here, fog and edge computing are somewhat similar one. So edge computing is one kind of fog computing, or sub part of like fog computing only. So the characteristics are similar only. Okay, similar only. So because of this desirable characteristics, nowadays the IoT applications are developed with edge computing, edge intelligence along with the cloud intelligence. Okay. Here you see the various applications which make use of this edge computing. Nowadays, you know, the smart traffic, smart city and it all. Here the traffic for traffic analytics purpose. Okay, traffic analytics purpose. In the roadside, some smart units are there. Through the smart units, they analyze how many vehicles are crossing that particular area, in what speed, and what are the different kinds of vehicles crosses every day, and several other parameters about that traffic also. So this is one of the application which make use of edge computing. Then another important thing is automated vehicles. In a few years, we find our roads will be occupied by automated vehicles and all. Suppose one pedestrian is crossing the road immediately, means here the automated car has to put the brake immediately. So it takes some immediate action. So for that, for taking such action, this edge computing play a vital role. It helps the automated car to take the action in an immediate manner. Similarly, video surveillance, you know, then manufacturing and the production side also to analyze or to detect the defects, okay, to detect the materials with the defects part and the severity of the defects. Here they use edge computing or edge intelligence. Second topic here is the role of AI in web development. Role of AI in web development here. We know the role of AI. Mostly it is nearly 90% website or web computing is occupied by the AI algorithm, maybe the machine learning algorithm or some solution in the form of deep learning algorithm and that all. So whatever may be the solution, it is classified into 3 categories. So one is experience, through this AI, we benefits benefits in three different categories. One is experience, huge user engagement. Second one is helps in modern web development. The third one is add functionality to the website. Okay. Now let us see how the AI, what does AI do in the web development here? We know the AI powered solution. If the website is equipped with some AI tool like chatbot or chat GPT means, so it analyzes the user behavior and the browsing pattern and the preferences and the pattern of interaction for personalize the websites, for making the website more appealing, more visually appealing to the user, as well as for making the recommendation. Okay, so we agree that, everyone agree that nowadays we spend most of the time in browsing through mobile or through laptop and all. Suppose if you take a survey about this time spent in browsing means, if you take a survey and if you plot it in a form of graph means the graph, we find some increased, some increasing, strike, some sudden strike happening in the graph. This is because of this experience huge user engagement, because here the AI solutions make the website as another more appealing one or more valuable one. That's why the users spend more time in that website. Okay, so this is the first important thing. Okay, make the website more engaged one, make the website more engaged one through this AI solution. Then the second one is it helps in the modern web development. Okay, so it helps the web developer to create a website in a faster manner, in a quicker manner, by doing several automatic tasks. By doing the task in an automatic manner, it helps the developer to create the code. No need to write the code from the scratch. It helps the developer to create the code. Then it helps the creator to generate the content. The content may be in the form of text or in the form of audio or in the form of image through various tools, AI powered tools. It helps the developer to create the content in a quicker manner, and also which is attracted by the customer also. Okay, so in this way it helps in modern web development. Then the third important thing is it adds functionality to the website. Okay, like some analytics task is added to the website. Some through this website also we can get some doctors, some appointments. So many functionality can be added in that website. Okay, so these are the three important functions performed by AI powered the website here. Then the reason why AI is important in the web development, these are the three important things. As I already told that, it helps the web developer to create a dynamic websites. So based on the user interest or based on the navigation pattern, customer navigation pattern, it make the changes in the website then and there. Okay, then and there. So it helps to design some dynamic websites. Second important thing, in the business angle, it helps the businesses to speed up their process. Similarly, it helps the businesses to change the strategy then and there. Change the strategy season to season, or change the strategy based on the age group of the customer and all. Okay. Then the third important thing is using the artificial intelligence can enable the website designer create more engaging websites. So another one important functionality of AI here is it helps the web developer in optimizing the workflow. That is, it optimizes the search engine algorithm, ranking algorithm, and so on. So let us see the 12 different ways how the AI helps the web developer to make the website more engageable one. So the first important thing is it helps the web developer to create a more personalized user experience, As I already told that, so the website can use machine learning model to adjust the content dynamically, then to make the recommendation according to the individual user interest. So so it improves the user engagement. So through this, what they benefit here is the business people get success by means of getting the long-term customer loyalty, then maximize the conversion rate. Okay. So through this, the business gets success because of this personalized user experience. And the second important way here is integration of chatbot and virtual assistants. Okay, so if you integrate chatbot and virtual assistant with the website means, so it helps the website developer to provide an instant answer to the answer to the customer queries 24/7. Okay, can it replace the human for answering, for giving the feedback, for giving the review about some product, review about some new item and all. The third important thing here is all these things are possible. That is personalized user experience, make the web page more engageable one. All these things are possible because of this technology. That is natural language processing. You know what is natural language processing? It's a subtopic of AI. So it enable the machines, enable the digital machines or enable the machines to get the ability of the human, like ability to get the details, ability to answer like a human being, ability to translate like a human being, ability to summarize things like a human being, ability to generate anything like a human, generate any content like a human being. So with this technology, the AI get more powerful. Okay. So keyword extraction, sentiment analysis, semantic understanding. These are the important key terms relevant to this natural language processing. Similarly, content summarization, auto tagging, then you realize the benefit of auto tagging here. Then language translator, Google Translator, So all these things are possible because of this natural language processing. Okay. So one of the best example here is GPT-4. So with this GPT-4, you are able to, GPT-4 is able to answer to the human questions, and then able to translate something, able to generate the content based on the previous content. And the fourth thing is content generation and the curation. So here, the first thing is content generation. So the AI-powered content generation tools can assist developer in creating the top quality or relevant content with a higher efficiency. What does curation means? Here, the AI-powered content curation system can recommend some third-party data sources to the developer or to the user. Okay, this is a major difference between the content generation and the content curation. Okay. And the fifth one is automated testing and the quality assurance. Okay, so the AI algorithms helps the developer to automatically test the websites. Okay, test the websites. So the ML algorithm can perform several tasks like detecting the bugs, analyzing the code patterns, or predicting the potential issues. So it's helpful for debugging purpose also. Then the next one is predictive analytics. So you know what is predictive analysis? The predictive analysis forecasts the trends of the user behavior, user requirements. So once we know the user requirements and the user needs means based on this user requirements or user behavior, the website automatically send a recommendation to the appropriate customers. So what's the benefit of this means? It ultimately improve the profitability, gain profitability or productivity of this business. The next one is image recognition and processing. Okay, so the AI solution, okay, the website along with the AI parts or AI chat GPT like tools, okay, and the deep learning algorithms are capable of recognizing the objects, then classification of the images and extracting some important information from the images. Also helpful for translating the image into equivalent text or translating text into equivalent image or converting the audio into the equivalent text. All these things are possible with the help of like image recognition and processing here. The next one is voice search optimization. We realize, we see most of the websites are equipped with this facility like voice assistance and it all. So this is very helpful for the user with a disability here. So with this facility, it able to answer the spoken queries, understand the various natural language questions, and it direct the customer to the correct website and it all. Similarly, next one is dynamic pricing or optimization. Then security enhancement. In the security aspects also, it improve the website security. Then sentiment analysis and feedback management. So here the AI algorithms are capable of analyzing the user reviews, feedback, the social media, the blogs, and based on that, it helps to improve the websites or improve the product quality and it all. And the last one is recommendation system. We are all using this recommendation facility provided by the websites. So the last one here, how the what are the tools used by the web developers to create the AI-based solution? Create the AI-based solution. What are the tools used by the web developer here? So the popular tools here, the popular tools are TensorFlow, okay, TensorFlow, PyTorch, then Keras, Scikit-learn, OpenCV, IBM Works. These are the popular tools used by the web developers to create some AI-based solutions. Next important thing is web content generation. How the AI helps the web developer to create a content. Okay, so here I classify the content into two categories. One is text-based content. Another one is image-based content. Image-based content. For text-based content, you prefer the transformer-based AI solutions. Transformer-based AI solution. The transformer-based AI solutions are effective in text content generation, like text-based solution, like language translation, chatbot, then summarization, then question answering, and so on. Whereas generative adversarial network, that is we are usually called as GAN network. Okay, this is helpful for generating like image for generating the images or converting the image into text or converting text into image editor. So these are the two important deep learning models helps in the web content generation here. So just I go through the transformer architecture. So here you see the various components here. So input may be the sentence or the sequence of words. So it is passed to the tokenization process, then embedding process, then positional encoding. After that, it is passed to the number of self-determining or mechanism. At last, it here chooses the correct output. Here you find the several statement. Among the several statements, it chooses the correct statement based on the probability value. Based on the probability value. Okay. Just I go through the various the role of each component in the transformer architecture. The first thing is tokenization. The tokenization split the given input into number of tokens, then embedding. So through this embedding, the input tokens are converted into some numeric vectors called embedding. So here it is nothing but the token is nothing but the features, okay, the features in the particular word. The features in the particular word is mapped into some real value number that is called vector or embody. And the third thing is positional encoding. So here the sentence means the sentence is formed by the number of words. The position of the word within the sentence is maintained through this positional encoding. So it add some location of the, so through this it add the location of the word in the particular sentence. Then it is passed to the self-attention mechanism. The self-attention mechanism, here there are several pauses are there. Depending upon your requirement, you can choose the number of self-attention and feed-forward network combination. So here what's the role of self-attention mechanism here is it compute the contextual relationship between the tokens, and then at last it passes to the softmax function. So it is used at the end to calculate the likelihood of different output. So because you at the output you find several number of sentences with a different probability. So out of n number of alternative, it's helpful to choose the sentence with highest probability. So that is appended to the input, and the whole process repeated repeated until we reach some end of the process, until we reach some satisfaction. Similarly, next one is GAN. As I already told, the GAN is used to generate the image in an artificial manner. So it consists of two important parts. So one is generated part, another one is discriminated part. Already the discriminated part is trained with some real images as well as some fake images. It is trained with the both images. So here in the generated part, it generates the image in the random manner. So it may be the fake image that is given to the discriminator. So discriminator model already trained with the real example as well as the fake example. So through while giving the new output from the generated model, that is fake example from the generated model, it compare its feature with the feature already retried. So based on that, it calculates the difference. So through this loss or through this difference, the generated model is again trained. So that is given as a feedback to the generated model. So with this feedback, it again generate one more sample. So through this, the generated samples are tuned to generate the samples which look like the real samples. Okay. So here you see how the GAN is helpful to generate the samples similar. Okay, samples which resembles the original one. Okay. So here you see the images of the celebrities which are generated by means of GAN. And today we see the different kinds of GANs also. So here another one application that is generating AI application, but it use some transformer model because the input here is text. This is for text translation. So here this model uses some transformer deep learning model for text translation. Similarly, chatbot and ChatGPT also works based on the transformer deep learning model. And the next one here, you see how computer vision and NLP helpful to generate the message. Here in the first thing you see this model. Okay, here this model make use of the image information as well as the text information to classify, to make us make a decision, it make use of the image information as well as the text information. Here in the bottom row, you see from the given image. Here the input is only the image. From the image, the deep learning model automatically generate the equivalent text. Okay. So here you see one text is here. Man in black shirt is playing the guitar. Okay. So the input is only the image. Here the deep learning model is trying to generate the equivalent text. So it's again comes under generate AI. Similarly, the generate AI tools are helpful for image translation purpose. Okay. So here you see one image. Here using the generate AI tools, the image is translated in this way. Some background information are added here. Similarly, here also the generative model play vital role in generating the images. Okay, generally generating the images looks like the original image. And here you see one example how the text input is converted into the equivalent image through this generative model. Here one text like an armchair in the shape of the avocado. Okay. Suppose one text is given in this way, means here the deep learning model or generative AI automatically generate the equivalent images. Okay. Then again the second one, some text input is given here, that is a stored front that has the word OpenAI written on it. Okay. So for this text, it automatically generates one image with the text OpenAI. The OpenAI is written, or OpenAI, the text OpenAI is displayed in different styles also. So this is the power of generative AI. Okay. So from the simple text, you are able to generate different pattern. In an easy manner. So another one example, this is a generative AI tool, OpenAI tool. It's an image generation tool that is DALL-E. So with this tool, you are able to generate the images similar to which appears the original one. Through this tool, I give this the person image as an input. In the first trial, I'm able to generate these two images. Okay. After fine tuning for several iterations, we are able to generate the images looks like an original image. It's like an original image. Next one is image to image translation. This is also possible through this generative AI. So actually, these illustrations show how the AI tools are helpful in the web content generation. Similarly, if you give the sketches in a drawing manner, means through the AI tools, it cannot. Okay, the AI tools convert these sketches into the equivalent wonderful images, colorful images. Similarly, for generating this image, I gave some text to the tool. While giving the textual description, it automatically generates this image. Then other generative AI applications are text to speech, audio generation, video generation, then image and video resolution enhancement, then synthetic data generations. So these are all possible with the help of generative AI tools. Again, you see the various AI tools which are helpful for web developers. Okay, just to go through various AI tools for web developers here. Here the AI tools play help the web developers to develop the front end as well as the back end. Let us see what are the tools used as a front end tools. Here the important thing here is AI powered chatbot and virtual assistants, voice user interface, image video processing, data visualization, and design assistance. These are the various front-end AI tools. Similarly, back-end AI tools are NLP and intelligent resource management. The tools names are given here. These tools are helpful for managing the resource, resources of the website, managing the resources of website here. Similarly, these tools are helpful for testing the content of the website for debugging purpose. Similarly, these tools are helpful for security purpose. Okay, now let us come to the end of this session. Let us see one a demo. So in the last year, we are from the last year onwards, we are doing this project for some real-time project. So that is project title here is Deep Face Recognition Based Automatic Attendance Registry. So the main objective here is main objective of this project work is develop an multi-face recognition based attendance system using the deep learning model. So we see in most of the industries and most of the organization, we see some face biometric based attendance system. Nowadays, they replace fingerprint biometric system with some face biometric attendance system. So that attendance system usually process the individual patient that devices, automatic attendance devices, process the faces, process the single face at a time. But here, with this project, we are trying to capture a group of faces. We are trying to capture a group of faces and trying to recognize multiple face at a time, using the deep learning model. So what's the purpose here is to overcome the drawback of some manual task. Okay, manual recording of attendance is time consuming one. Then it leads to a problem like the proxy attendance, some delay in attendance registering. To overcome this manual attendance, we go for like ID scan, okay, ID card scanner or fingerprint scanner system. So, during the COVID-19 period, the touch-based, like the fingerprint attendance systems are shut off, okay, in a complete manner, okay. So, this is a motivation for developing the touchless-based attendance system, that is face recognition-based attendance. Okay, this is a motivation. That is, we are trying to develop some touchless, at the same time, reliable attendance system, as well as the characteristics is non-intrusive one, non-contact-based attendance system. Okay, how it helps the education field means it helps the teachers to manage their classroom status of the students. With this, you can easily count the number of students present in the particular class. So it improves the quality of the classroom education also, and also provides some effective technical support and solution for the education field also. So the basic here is, our face also contains some unique features, okay, unique features. So they are called as facial landmarkers. What are all the facial landmarkers are? Some eye position, that is left eyebrow position. Similarly, right eyebrow positions. Similarly, left eye, right eye, then upper lip portion, lower lip portions, and nose portion, the corner point on the nose. So these are all the important key pointers or important landmarkers of the important key pointers which helpful to identify or verify the face, which helpful to identify or verify the face uniquely. Okay. So first, so here let us see what's the difference between the face detection and face recognition. You all know what is face detection. Here, face detection means face detection usually gives the answer for the question like, is that a face present in the image? Okay. So the answer is the face detector usually gives the result like in this way. It gives the 1 minute. Actually, usually the face detection algorithm identify the location of the faces. Okay. Suppose if you give the entire person image means or any image means any image with some human faces means it identify the face, it identify the region of the face. That is the role of the face detection. Okay. Where the face is located, it gives the answer for where the face is located. So it draws some boundary box around the face. So it gives the X and Y coordinates of the boundary box. Okay. Second one, what is face recognition means? It answers the query of whose face is that? Okay, whose face is it? Okay, whose face is this? So that answer is obtained from this face recognition algorithm. Here you see the complete system architecture of our multi-face recognition system. Here there are three important things. One is customer, the data set preparation is the tedious one here, data set preparation. The second important thing is multi-phase deduction. Then after that, the deducted phases are passes to the face recognition part. So the entire task is divided into three tasks. The first thing is data set creation. Second one is deduction. The third one is face recognition. Okay. Let us see how the data set is prepared. Okay. So here we prepare some custom data set with respect to the students of our own course. So here in the university, we find student passport size photos, which is normally submitted at the time of admission. So we took that photo, individual student photo, some passport size photo. Then it is pre-processed. Then after that, using some face detector algorithm, the face region is detected. Then after that, the face region is cropped from this remaining part. Face region is cropped. Then after that, face annotation is face. Face annotation. After that, some face annotation is done. Okay, while annotating, here the face is okay. Face region is marked with some boundary. That means for each face, it stored the X and Y coordinates of this boundary, as well as the face ID. Okay. Suppose you want to display the name of the person as name of the person means here you store the boundary coordinates along with the name of the person. Suppose you want to display only the register number or roll number of the student means here you store the boundary coordinates along with the register number of the student. So that is happening in the face annotation. Okay. But here we find only minimum samples. For each student, we are able to get only one photo, only one original photo, but the deep learning application need more number of samples. Okay. That's why go for like face augmentation. Here we started with some normal geometric phase augmentation. So through this augmentation, we are able to generate more number of samples. So in this project, initially we generate some 20 samples for each student photo. 20 samples for each student photo. Nowadays, we try to add more phase augmentation technique to generate more number of samples here. Okay. So in this way, the custom data set is prepared here. Okay. Then after that, while testing here in the classroom for the testing purpose, here in the classroom, one pan tilt and zoom type camera is installed, fixed in the classroom in a particular place. The classroom size is like 8.5 meter into 8.5 meter, like a square shape, shape like a classroom only. So while testing, what we plan here is after here once the staff once the staff start to take the attendance, he has to log into the particular system. So after logging to the system, here the camera will be enabled for a few seconds. At that time, it move 180 degree or it scan 180 degree to take a screenshot of the classrooms. So in this way, the screenshots are taken. Then the screenshots or the group photo. Then the group photo is sent for pre-processing. Some noise is removed. After that, that is given to one phase detector. Here we use some MTCNN. MTCNN, you know, multitask CNN. So the multitask CNN is able to detect the phases, even though the face is tilted, even though the head post is are changed, it is able to detect the phases correctly. That's why we choose MTCNN for phase detection. After that, it is given to the face recognition algorithm. Here for the face recognition, we prefer the standard FaceNet. You know, the FaceNet. It is already trained with some public data set. Okay, it is already trained with some public data set. So before giving the testing image, already the FaceNet is trained with the data set, custom data set, our own custom data set. Okay. So during the testing, if we pass the screenshot or a snapshot of the classroom image, means it automatically recognize the faces. Here for the illustration, for the illustration purpose, we draw the boundary around this face, as well as here we plan to display some serial number or roll number of the student. Instead of name, we plan to display the serial number or roll number of the student. Okay. So through this project, we are able to get some 87% of face recognition accuracy here. So I'll explain the step-by-step process here. The first thing is custom data set preparation. So first we choose, as I already told, I took the images which are submitted, which are available in our campus. So here for each student, we are able to get only one original image, some passport size images taken for the training purpose. So here only one image is there. So we go for like face augmentation. We did some face augmentation. So in the face augmentation, you know, some two kinds of face augmentation techniques are there. So one is geometric augmentation, geometric transformation based method. Another one is GAN based method. But so far we did only geometric transformation method. So in the geometric transformation method, we apply rotation by varying the degree of rotation, by changing the brightness level or a contrast level, by changing the percentage of the noise level. In this way, we generate more number of samples here. So for this, we use TensorFlow Keras. The function name is image data generated. Through this, we are able to generate more phase augmented images. So this is the phase augmentation results. Here we apply some horizontal flipping, vertical flipping, rotation, brightness, noise addition, and noise addition. So through this we generate generate some 20 samples, 20 samples of each original image. So the input image is this way only. Then it is processed to the phase detector. The phase detector detects only the phase region. Then the phase region is cropped. Then after cropping, the phase augmentation is applied to generate more samples. So here we employ the MTCNN phase detection. So this is the result, normal result of MTCNN. So the MTCNN usually draw the boundary box around the phase region, as well as it find the key important phase landmarks. Okay, that is the position of the left eye, position of the right eye, the nose point, and left chin and right chin. These are the important key markers, important key position of any phase. Okay, so this is normally determined by MTCNN phase detector here. Actually, this is determined by 3 different phases. Here, if I give some image in this way, means in the first pass, it generates more number of boundary box. Then in the second iteration, it tries to remove the unwanted boundary box. It keeps only the closed boundary box alone, accurate boundary box alone. In the third phase, it remove the unwanted, again fine tune the boundary box, as well as it find the key points in the face, key points in the face or facial landmarkers here. So this is the output of any MTCNN here. So after applying the MTCNN for the testing image, you are able to get this result. So they draw some boundary box around the faces, even though the face is tilted. Okay. So it is able to draw the faces, but in some cases it failed to detect. Okay, failed to detect here. Some misclassification also there. Very. And the next thing is face recognition using the FaceNet. So for the face recognition, we use we employ only the FaceNet and the popular deep learning model, that is FaceNet. So after doing the face recognition, we get the results in this way. In addition to this boundary box around the face, it displays the serial number. Here we annotate the face by giving the serial number of the photo, serial number of the student alone. So that's why display the serial number of the student, that is 331, 539 and all. So in this way, a system recognize multiple phases at a time. So this is an illustration how FaceNet identify the face. So here, here the input to this FaceNet is human face. Normally the output of the face detection is given to the FaceNet. So from this face region, it identify the key points or features which uniquely identify individual face. So that is again converted into some real value. Here number of real value obtained from each face is 128. That is called 128 size embedding. This is called 128 byte, 128 size embedding. Then with this 128 embedding alone, it classified the phases. It classified the phases. For the classification purpose, it used some loss function like triplet loss function or Softmax function for the classification. But the classifier take the 128 128 embedding as an input for multi-class classification, because it comes under multi-class classification. For this classification, it takes the 128 embeddings. 128 embedding is nothing but 128 some real values, real values obtained from each phase as an input. Then after successful training, we are able to get the correct classification. This is the hardware, software, and camera specification we used in this project work. And the hyperparameter settings used in this project work. This is the result. You take the screenshot, snapshot of the classroom. Then it is passed to the NTCNN for deduction. Then it is passed to the face recognition, FaceNet. So it recognizes the faces. Some misclassification is there. So this is the result. So through this, we are able to get some accuracy, like average accuracy of like 0.87 like this. 0.87. So what we conclude here is still some, even though we are able to get face recognition results, some challenges are there. Okay, challenges are there here. So one of the important challenge here is here the seating arrangement is only flat type only. So if you change the flat type, if you change the seating type as some gallery type, means you can improve the face recognition. We can solve the problem that arises due to like occluded faces and overlapped faces. Because of flat seating type, the faces are overlapped faces are there, then some occluded faces are there. To overcome this problem, we can go for like different seating arrangement. Then other challenges we realize here is here we're able to take only a single sample for individual student, only the frontal face alone. But in reality, the student pose may be vary. Similarly, expression may be vary. So more original samples are needed to improve the accuracy, more original samples. Another important thing is already told that some challenges like occluded faces or partially occluded faces and like overlap faces. So to address this challenges, we need more augmentation techniques. Okay, we are trying to employ like GAN-based augmentation techniques, customized GAN to address the special challenges, specific challenges due to like partially overlapped phases at all. And one more thing, as I already told that seating arrangements, if you change the seating like gallery type means most of the problem will be overcome. And one more important thing here is, but it at the same time, the face recognition should differentiate whether the photo is a live photo or the photograph of any student. So that thing also, we think about that also. We need to add one more model to differentiate whether the photo, whether the student photo is live one or some earlier photo of that student. So these are the challenges we face here. And these are all about the face recognition system. So normally the popular data sets used by any face recognition system is listed here. Let's go through that. VGG face, Cassia web face, and Selif A, FDDB, and several data sets there. But here we are trying to do the face recognition for our students That's why we prepare our own custom data set. So various face detection models, popular face detection models are created. Then face recognition model, popular face recognition model. Let me conclude with the FaceNet. Here, the power of FaceNet here. So here the FaceNet model comes under CNN. Everyone know the convolutional neural network based architecture. It comes under CNN based model. That's why it perform multi-class classification. So here there are two variants are there, but here we employ only inception model. The power of what's the power of inception model here is the inception model here employ multiple size kernel. Okay, in the single layer, it employ multiple size kernel like a 1 cross 1, 3 cross 3, 5 cross 5. Okay, so what's the use of this kernel here is through this kernel it is able to recognize the images of different size or objects of different size at the same time. The same simultaneously it is able to capture the objects of different sizes. That's the power of inception model. So with this inception model, it is able to recognize the faces with the different sizes also. Then another one feature of FaceNet is triplet loss function. Triplet loss function. So here the loss function make use of three important components. One is anchor, another one is negative, and the third one is positive. I'll explain what is anchor and negative and positive with respect to the sample. Here the anchor is the original sample. The person, okay, suppose I take one the student with register number 1 means that is the reference image. That's the reference image that is taken as an anchor. For the register number 1, the student with the register number 1, through face augmentation, I generate more number of samples. One of the sample is taken as the positive image. Another sample is taken as the positive image. In the positive image is nothing but the same person image, the same person image, but it's a different and the photo. It's a different photo, but the same identity. That is the positive image. Then the next one is the negative image. Negative image is the photo of the other student. Photo of the other students is taken as a negative image. So with this model, so the triplet loss function take these three components. Okay, one is the reference image, then the sample of the same reference image, that is the positive image, totally different image, that is the negative image. So through this triplet loss function, it tries to minimize the distances among the intra-class, tries to minimize the distances between the anchor and the positive sample. At the same time, maximize the differences between the interclasses, that is maximize the differences between the anchor and the negative sample. Okay, so here the FaceNet parameters are trained or fine-tuned in order to minimize the differences between the anchor and the positive sample. At the same time, maximize the differences between the anchor and negative sample. Okay. So this way only it is trained here. Okay. Okay. That's all about. So this is a triplet loss function used in the FaceNet model. So through this thorough training, the triplet loss minimize the distance between the anchor and the positive because both of them have the same identity. That is, minimize the distances between the photos of the same class and maximize the distance between the photos of the different student. That is, anchor and the negative of the different identity. Thank you. Thank you so much. If you have any queries?
Participants, you can please raise your queries to ma'am.
good evening, madam. Especially deep learning models and the automatic attendance registering was very interesting. Thank you, madam.
Thank you, sir.
Sorry, if any queries are left out, can please raise. Otherwise, we can convey our thanks to ma'am and end up the session.
Thank you, ma'am.
Good.
Thank you so much.
Okay, thank you,
Thanks a
ma'am.
lot for giving the opportunity. Thank
Sincere
you,
thanks to
participants.
Juliet, ma'am. Sincere thanks to Juliet, ma'am. It was a
Thank you, ma'am.
very explanatory session, very explanatory session. From the basics to till the project explanation, it was very explanatory. So we understood the concepts in a very clear and precise manner. So the project and all is shown motivated us also to continue with some projects like this. Thanks for sharing your experience with us, ma'am. Thanks a lot. Participants, on behalf of all of us, I convey a sincere thanks to ma'am. Thank you, ma'am.
Thank you so much, ma'am. Thanks.
Dear participants, today we come to the end of the day 2 of this 6 days online Atal FDP. So have a pleasant night. Tomorrow by 6 p.m. we will be joining for day 3, the session 5 on this 6 days online Atal FDP. Hope you all had a nice time. Thank you all participants.
Excuse me, ma'am.
Yes, please.
We didn't receive the second session feedback, ma'am.
Ma'am, it will be posted shortly. It will be posted now. It will be posted, ma'am. Please hold for a second. It will be posted now.
Already